Azure Durable Functions are a great way to remove a lot of that plumbing that comes with a workflow-based system. If you can model your system as a chain of events and functions, then chances are you can simplify your code a lot by using durable functions. In my previous video we saw a use case, and now it's time to get started in Visual Studio and get going with some code. Now, before we can get started, we need to make sure that you have all the right bits installed. You will need Visual Studio, the Azure SDK and the Azure Storage Explorer. Now, I assume that you know how to get them, and if not, then this video might be a bit above your level. You will also need a working knowledge of C#. Now, we covered the use case, so we can really get started here. And if you haven't seen my previous video, I really encourage you to do so, because that explains the use case that we are going to build, so you know where we are going. And it helps with understanding me, well, the bits about the code of me at least. So, as promised, finally, here's Visual Studio. Let's get started. Okay, just a regular file, new project stuff that will get us here. Now, since all durable functions are just Azure Functions, we choose an Azure Functions project template. You can search for it here, or if you have used it before, it will probably be here on the left side somewhere. Okay, so then we click Next and we give it a name. And how about Function Lovers Registration? And then we click Create. It's funny. We ask for Create, but before that happens, we must answer a couple of more questions. I mean, it needs to know the version of the runtime. We'll pick version 3, which is based on .NET Core. And we also need to specify the storage account. Now, since all of our data will be stored in some sort of Azure storage, Visual Studio wants to know where to put our stuff. Now, in our case, I go for the storage emulator. Speaking of the storage emulator, I use the Azure Storage Emulator here. Now, if you go to the Microsoft website, you can see that it says that you should be moving to Azurite, which is the new platform. Now, you could do that, of course, but you will run into a problem. The official release of Azurite right now does not support table storage emulation yet. They are working on that, and there is an early version available, but it's not done yet. And as we will see in another video later on, durable functions rely on table storage a lot, and that's why I'm now staying with the storage emulator. If you watch this in the future, which, thinking about it, you are, since you are not right now in my room here with me, things might have changed, and Azurite might have all the parts that we need. In that case, please use it. It really doesn't matter. I mean, the endpoints and connection strings are the same, and the runtime will have a place to store its data, and that's all that matters. But I use the storage emulator for now. So, with that out of the way, we can choose what kind of function we want, or rather, what kind of trigger we want. Azure Functions are functions, but they are part of the serverless way of architecting things. And I need to spend some time on that as well. Okay, first, I think that the term serverless is wrong. We should have called it server agnostic. Okay, I can see that if you run on a laptop, then you can claim to be running serverless. And although that's technically correct, that's not the point. The idea behind serverless is this: you don't care where your code runs. You don't care about the hardware, the location, the amount of memory, the CPU, the OS. Of course, you will care about this when you are deploying and scaling, but when you are architecting your system, you just don't care. I mean, you write functions, and when you work in C#, static, stateless methods. They must be running somewhere, but you don't care where. If one of those functions is used a lot, you want to be able to distribute the load over multiple machines. Heck, you might want to distribute it over the globe. And functions calling other functions should be completely unaware of this. They just call methods somewhere. Okay, we do specify classes and C# projects in Visual Studio, but that's just because that's how the compiler works. We don't care about these classes. We just write functions. And of course, in the other parts of the system where you handle all the business logic, then you would care about code structure, classes, inheritance, and so on. But when it's all about the Azure Functions, you don't care. And again, since durable functions are just Azure functions, that also applies to us. So we don't think about the server, we are server agnostic. Okay, I'll stick to it. We are serverless. But that leaves us with one question. If we have these functions floating around in space, and again they're just static C# methods, then how can we call them? Well, we don't. Most of the time, not directly at least. We'll have someone or something else call them. But we need to define how they can be called. And this is done through something we call triggers. As the name implies, this is what triggers our methods to do some work. So we have HTTP triggers, and this means that someone or something can call that function through an HTTP endpoint, such as a REST call. We can also have queue triggers. We specify what queue we want our function to watch, and as soon as something is placed in that queue, our function will pick it up and starts doing the work. And there are others as well, such as table-based and event hub-based and so on. And we must pick which one we find the most appropriate. In this list, next to the triggers, we also find Durable Functions orchestration. And that's what we want. Now, this is not technically a trigger, but yes, it will generate a trigger for us, or rather multiple. So let's do that one. And here we are. Visual Studio has provided us with a nice Hello World style application, and that gets us going. Now, if you are new to Durable Functions, this can get you on your way. However, we don't need it. So let's get rid of this. And let's start to do some real code. Again, Durable Functions are just Azure functions. They form a workflow, as we saw in the last video, but something has to start that workflow. And in our case, we have Annette who wants to register for one of our events. So she goes online or she uses the Xamarin app, and that in turn calls our system with the data. And that is our entry point. In this case, we will have an Azure function with an HTTP trigger. In other words, our first function is going to be called with a plain old regular REST request. And let's make it post. After all, we are updating the system with new information, right? But since most developers default to GET, we will allow that as well. It doesn't really matter. So we write that as follows. Okay, granted, this is not very interesting, but at least we have something. This is not an Azure function yet. Let's make it one. Again, we must specify what trigger we want. Now, we already said that we want this to be an HTTP trigger that accepts posts and gets. So we add this to the parameter line. Okay, what's going on here? Well, we tell the framework that we want to use the HTTP trigger. So this can be called with a REST call. You set this up in an HTTP trigger attribute. Now, we don't do any authorization here. We would have several options to do authorization, such as on an app level, on a function level, or admin only. But we don't care for now. Anyone can call us here. Don't do this in production though. We will cover security in a much later video, but for now, this is just fine. And then we specify that we need to get data in an HTTP request message type called request. We want to use the dependency injection capabilities of the framework as well. We want to use the default logging system that allows us to display what's going on. So if we specify this as well in the list of parameters, then we automatically get a logger. Dependency injection sure is handy. I mean, we can just specify what we need, and if the runtime has this available, then we will get it. There is some sort of variation of this called binding. And bindings are a sort of injection, but they bind our code to something else that's already running. The cool part about bindings is that they can be both input and output. In other words, we can use bindings to get data from the engine, but also to send data out. Okay, this may sound a bit vague, but let me show you. Well, I'm going to show you the input part first. The output part will be part of a later video. Now, if we want to use the workflow capabilities of the system to run a workflow, remember the steps? check the data, check with the other user groups, send emails to the board, handle responses, and then finalize the registration. Okay, then we need access to the workflow engine. The workflow engine is what takes care of all that plumbing that I was talking about earlier. That workflow engine is available in the form of an Azure Durable Orchestration client. And we can get one of those instantiated for this specific request by using binding. So we add the following parameter to our parameter list. Now this will inject an instance of a class that implements that interface. And by using the attribute durable client, we tell the system what we want. And this is stored in starter. Okay, so this is the list of parameters. We have the HTTP trigger, and all associated data with an HTTP request is stored in that HTTP request message. We have an instance of the durable client in the form of an Azure Durable Orchestration client in starter, and we have a log instance so we can see what's going on from the outside. We need to do something else before we can implement the body of this function. All Azure functions, and again this is just a regular Azure function, there's nothing durable about it. They all have a name. Now I'm not talking about the name of the C# method. That's just an implementation detail. I mean, we could have given it any name. Now we need to specify the name that the user can use to call this. And we need to set it in an attribute. And I think that register attendee sounds just nice. And yes, that's the same as the name of the method, but that's just because I like my code to be readable. Later we will see that we can and we will create functions with different names than the method names. So, here we go. And that's it. Well, almost. We need to return something to make sure that the compiler doesn't complain. Oh, and it will complain about that async. Well, we'll fix them both in one go. When the client application, whatever it may be, calls this through a normal HTTP call, then we expect some data. Later we need to tell the workflow engine what data to use to do its work. So let's create some data structures for this. So I create a new folder and just a namespace DTO, and in that I add a new class called potential attendee. It's potential because after all there are so many things that can go wrong. And it looks like this. Well, there's nothing fancy about this. We want the name, email address and the meeting date. Now if we go back to our function, we can get the data from the request. We assume that the client will pass this on in the body, so we can retrieve it as such. Okay, in the real world we need to check this, of course. I mean, we cannot assume that the client will always pass in the right info, more likely than not. But for us right here, this is enough. So quickly return something that Visual Studio will compile our code. So we have a function that can be called from the outside. We have a way to get some data, so we can start testing. Now I use Visual Studio Code with a REST client extension for my testing needs. We could be writing unit and integration tests, but that's maybe a topic for another series. For now, let's go with Visual Studio Code. If you want to use Postman, go ahead. But first, press that magic button F5 to start our app. If all goes well, you will have this result. A nice console window that tells us that everything is fine, and we have one function. And that we can use get and post to call this URL to get things going. Oh, that register attendee that you see is the one that we specified in the function name attribute. This is not the C# name of our method. So let's copy this and paste it in code. We'll make it a post and we'll specify that we want to pass the payload as JSON. And now the payload itself. And we can send this. Great, we get a 200 OK back, which is indeed what we expected. And if we look at that console window, we can see that we indeed called register attendee. Okay, let's use the logging to have a bit more info. Okay, just for fun, let's run it again. Start it up and use your preferred testing tool to test it all out. Oh, one thing, I am using log warning here. Not because this is a warning, but this gives me a nice different color in the output so I can easily see what's my log and what comes from the engine. Again, in production you wouldn't want to do this like this, but hey, you probably also won't use console logging to track your apps. you'd better off using something like Application Insights. Again, not for this series. I want to focus on the durable functions part. Great! That's all fun and so, but there's nothing durable about it. So let's do it right now. Again, this register attendee function, it's just the entry point, a way for the outside world to call us so we can start the workflow that we discussed a couple of times already. The workflow consists of a set of Azure functions, and together they form a chain of code that parse data and, well, it does stuff. We don't call those functions. The workflow engine does. And we call that an orchestration. Now what we need to do is to start that engine or orchestration, and that can be done through another Azure function, but this time it's a bit different. So let me show you the outline of it first. This should look familiar by now. It's an Azure function, so it has the attribute function name, and that's the name we'll use to call it, just as we did with the register attendee. Just for clarity, I have given it a slightly different name than the C# method name, run registration flow. Again, the name of the method is not important. We'll never ever call it by that name. Azure functions are called by their function names. Now, since this is an Azure function, we need to specify the trigger that calls this. And we use the orchestration trigger. This means that this function is called when a workflow or orchestration is started. Okay, I shall from now on call this orchestration, since that's the actual name. We get an instance of an iDurable orchestration context in the variable context. And this is an instance of the workflow, orchestration, especially made for this instance. So when we want to register a potential attendee, all their data is part of that context. It's isolated from all the other contexts that might have been fired at the same time. And of course, I also added the logger. We left the body empty for now. So we have a starter function that we can call from the outside, and we have the orchestration. We haven't started it yet, so let's do that right now. Let's go back to our register attendee function, and then we'll add the following line. Okay, so we have this starter, which is an instance of iDurable orchestration client, and we can use this to start a new instance of the orchestration. We give it the function name, or the Azure function that has the correct trigger, thus an orchestration trigger, and we can give it some data. This will start the workflow and then returns a unique instance ID that we can use later on to check stuff on our flow. We will use this instance ID later on, but for now, leave things as they are. Okay, we're almost done with this lesson. We have done a lot, and I hope that you've learned a thing or two about Azure Functions. And if you already knew all of this, then I hope this has refreshed your knowledge on Azure Functions a bit. At least I hope that you've seen how to start an orchestration. And the next video we will expand on this a lot more and actually do something useful. And we will also see how this all works behind the scenes. Oh, I want to do one more thing. Let's get that potential attendee data in our running orchestration. After all, what's the point of handing it over when we don't use it? So, in the run registration function, or the run registration flow C# method if you prefer, add a return type and the following lines. We get the potential attendee from the context. Now, we use the data to start the orchestration, so the context holds on to the data for us. And the result, the registration result, it's just a simple class and an enum that we put into our DTO namespace. This is simple enough, right? We will expand the registration status enum later on when we find more reasons to keep people out of our user group. Just kidding. Well, we will expand on it, but, well, never mind. We'll expand on it later on. Run it. Use Visual Studio Code. Marvel in the results. And remember, we're not really doing anything so far. But hey, I did promise you Visual Studio in the last video, so that's what we did. The next video will, like I said, show you some real work. We're going to do step 1 of the workflow, the checking of the data. And we will use that to explore how this works behind the scenes. We will investigate the inner workings of durable functions before we will expand and see the real power of it. All that we did now was necessary setup before things can get interesting. So If you haven't done yet, please subscribe and make sure that you hit the notification bell so you don't miss any videos I put up where we will explore durable functions and other stuff I think you might find interesting. Until then, thanks for watching and I'll see you the next time.